Welcome back to MS3.2. So hopefully you had a chance to look at some of these other ones in terms of naming these alkanes. So if we look at this one, here's some more to do. Now just pay attention to the carbons, and you want to find the longest chain that you can go. So if I started here, for example, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. But if I go this way, 1, 2, 3, 4, 5, 6 or 6. So this is my longest chain. And again, you're only worried about carbons. So so there's 6 carbons there. So it's going to be something hex, and they're all single bonds. So it's hexane. Okay, and we have to number. Now let's look at what else we have attached here. Here we have this it's C bonded to H3, 3 H's. So of course we know that's a methyl group. And down here is a methyl group. So both methyls. Now we have to number it so that we get to the methyl group the soonest. So 1, 2, 3 is my first methyl. Whereas over here, 1, 2 is my first methyl. So we would number it from this way. So 1, 2, 3, 4, 5, 6. Okay. So we numbered from here. So at position 2 there's a methyl, and position 4 there's a methyl. So 2, 4. Now since there's 2 methyls, we have to use the prefix, let's see, mono, di, tri. So it's di. So if you look at your pink periodic table booklet, page 4 has those prefixes, mono, di, tetra, penta, and all those. So 2, 4. Dimethylhexane. There we go. Doing the next one. So we can see that this is going to be part of the longest chain. That's a really long section. If I go here, 1, 2, I can still go further by going another way. So going this way. And then if I turn up here, I go 1, 2 more of them, or 1, 2 more of them. So it doesn't really matter which way I go. So 1, 2, 3, 4, 5, 6, 7, 8. So 8, of course, is oct. They're all single bonds, so it's octane. And again, I have to see what I have here. So over here, a CH3 is a methyl group. 2C, CH2, CH3, that is an ethyl group. CH2, CH3, there's another ethyl group. Okay. So I have ethyls and methyls, and again, remember which one comes first. We do this alphabetically. So ethyl is going to come before methyl. So let's see here. So, oh yeah, numbering. 1, 2, 3, 4, 5 is where my first attachment is, but I can likely go lower than that. 1, 2, 3. So yes, I'll number it this way. 1, 2, 3, 4, 5, 6, 7, 8. So notice they don't show the lines here. That's okay. We can either show the bonds between carbon, or if they're just carbons side by side like this, we assume they're bonded. So at positions 3 and 4, I have my 2 methyls. So 3, 4 dash diethyl. And then my methyl is also at position 4. So I just simply say dash 4 dash, and I don't say monomethyl, I just simply say methyl. So 3, 4, diethyl, 4, methyl octane. There we go. Now, if you look at the next page, we'll try to do vice versa. Go backwards. So here's the name, and you draw it. So now I'm going to draw it just simply as a long chain and then do the branches after that. So the key thing here is to look at this. Pentane, those are 5 carbons. 1, 2, 3, 4, 5. Notice I'm leaving room here to write down H's. I think I did that. Did I do that backwards? Yeah, I think I did do that backwards. Let's just put the carbons there first of all, without a line. How about that?
or, because I know I'm going to have to draw H's here, right? At the back end of each carbon, I'll draw the bond. There we go. And I'll just number it. 1, 2, 3, 4, 5. So over there, so I have my 5. I have them labeled from left to right, which you could do every time if you get a chance to draw them. So at position 3, there's an ethyl. So position 3, there is an ethyl. And an ethyl is made up of 2 carbons. Now I need to draw H's here, right? This carbon is bonded to 1 carbon, so it needs 3 more H's. This carbon is bonded to 2 things. It needs 2 more things, right? And those 2 things are H's. Because we know what the ethyl group and methyl group are made of, because we have that little chart from earlier. So right here, ethyl, methyl. So we can always have that, and you'll have access to that on a colored sheet that you'll be able to use. So 3-ethyl, that's taken care of, and I could have put it above or below. It doesn't matter because remember it's allowed to rotate. At position 2, I have a methyl group, which is a C. It's bonded once, so it needs 3 more bonds, and those 3 more bonds are H's. All right, now I just have to fill in the H's on my structure. So this carbon is bonded to this carbon, so it needs 3 more H's. This carbon is bonded to 1, 2, 3 things, so it only needs 1 H. This carbon is bonded to 1, 2, 3 things, so it just needs 1 H. This carbon is bonded to 1, 2 things, so it needs 2 H's. And this end carbon is only bonded to 1 other carbon, so it needs 3 H's. There we go. Maybe pause the video and see if you can do this one, the 2,3-dimethyl methyl dimethylhexane. So if you had a chance, hex is 6. So I just draw the bonds on the back of each carbon just because I know I'm going to have to put H's here. And I'll number it 1, 2, 3, 4, 5, 6. At positions 2 and 3, we have methyl groups. We have 2 of them. So at position 2 and 3, 2 methyl groups. Then of course what's left is just to fill in the H's here. The N carbon is only bonded to 1 other carbon, so it needs 3. This carbon is bonded to 1, 2, 3 things, so it needs only 1 more H. This one needs 1 more H. This carbon bonded to 2 carbons, so it needs 2 H's. Same thing with this one. And this end carbon is bonded to 1 other carbon, so it needs 3 H's. Good. Now the last one here is cycloalkanes. These form ring structures. 5 and 6 membered are the most stable. They can take on conformations in which their bond angles are very close to 109.5, that tetrahedral angle. Small rings are quite strained due to being less than stable tetrahedral arrangement. So we can see here we have, if I was to kind of draw what this really looks like, I guess we could just go with that. So if I look at each carbon, this carbon is bonded to this one and this one, so it's bonded to 2 things, so it needs to have 2 hydrogens. And of course we simplify that to writing just simply CH2. As a shorthand, hey, we can get away with just simply writing a hexagon shape, because that implies that at each vertice or each point, there's a carbon and it's bonded to the appropriate number of hydrogens. Cyclopentane, 5 carbons, 1, 2, 3, 4, 5. There we go. Cyclopropane, prop is 3, so carbon, carbon, carbon. So the vertices of that triangle. It's that easy, ladies and gentlemen. And of course you can get away with just simply writing the hexagon shapes, or pentagon, or triangle. The final thing here, reactions of alkanes. Alkanes are rather unreactive due to the presence of CH and CC, which makes them nonpolar solvents. Since they're nonpolar, they're good at dissolving other nonpolar things. One commercially important reaction, however, is the combustion of air, which is the basis of their use as fuels. All right, so you should be able, the assignment deals with a lot of drawing and answering a couple of questions. You should be okay with that. Just come back to here if you run into a snag, and see how we can draw it, or if it's already drawn, how we can name it, and looking at those steps that we used to name it. That's a key thing to note. And of course, the more practice you do, the better you'll be at remembering these steps right here. So again, you find the longest chain, look for the base name, which consists of the longest continuous carbon chain, number from the end that's going to give you to the closest attachment the soonest, name the attachments or substituents in terms of alphabetical order, and then if you have to use mono or di, you can do that. All right, we'll see you again.